Welcome to 2.1, Differentiation and the Gradient Function, and your introduction to calculus as taught in math studies. Well, differentiation is the branch of mathematics that deals with gradient functions of curves. Now, you know gradients from straight lines, and you know that it's another name for slope. From that, we know that the gradient measures how fast y is increasing compared to the rate of the increase of x. Now, the gradient of a straight line is a constant, which means its direction never changes, and the y value increases at a constant rate. To calculate the gradient of a curve at a particular point, you need to draw a tangent to that point. So a tangent is a line that touches the curve exactly once. So you can see that my tangent is touching the curve here at 3, 9, which we call the point of tangency. And you can see here that 2.35 is another point on that line. So we could use those 2 points to find the gradient of the line, which would give us the gradient of the curve right at that point. But what would it look like if we chose 0, 0 as our point of tangency? Let's look. There's a line with 0, 0 as the point of tangency. What about -3, 9? It's going to be right about there. So the direction of a tangent to the curve changes as the x-coordinate changes. And we can see from there what we already kind of knew, which is that the gradient of a curve is not constant. So how do we deal with that? Well, for any curve, y equals f of x, where that is y is some function of x, which is not a straight line. Its gradient changes for different values of x, and that gradient can be expressed as a gradient function. So, to differentiate a function, you find the gradient function, which is also known as the derivative. So any function you have written in the form y equals ax to the n, the gradient function, or the change in y over the change in x, can be found by taking this value of n and writing it out front, multiplying it by a, keeping x, and then taking that exponent to one number less, or n minus 1. And as functions can also be written f of x instead of y, you follow the same process. You take this value here in the exponent, which is your n, you multiply it by a, which is the value in front of x, and then subtract by 1 in the exponent. And this process is valid for all values of n, both positive and negative. And you really want to be working with them initially in exponential form. So if you end up with a fraction with x to the n on the bottom or in the denominator, you're going to want to change that to x to the negative n while you're solving. Let's take a look at how this works. All right, I've been given y equals 4x to the 7th, and I want to find the gradient function, or the derivative. I need to identify what is my n, what is my a. Well, here, my n is equal to 7, and my a is equal to 4. So then, my derivative, dy over dx, equals, n comes first, 7, times a, 4, x to the n minus 1. My n is 7, so that is 7 minus 1. All right, so 7 times 4 is 28. X and 7 minus 1 is 6. So for the function y equals 4x to the 7th, the gradient of that curve at any given value of x is 28x to the 6th. Let's do some more. Here I have f of x, and I'm looking for f prime of x, which is looking for the gradient function or derivative. My n equals 5, and my a equals -3. Therefore, f prime of x is going to equal n, which is 5, times a, which is -3, x to the n, which is 5, minus 1. Okay, 5 times -3 is -15. X to the 5 minus 1 is 4. Well, that's all fine and good, but not every function only has one term. If you look at number 3, I've got 3 terms. And the way that we're going to deal with that is we are going to find the derivative of each one. So for this one here, I have n equals what? Well, 1, right? N equals 1. So then I have a equals 3. For my next term, n equals 2, and a equals -4, because that's the coefficient of that term. And finally, for my last term, n equals 3, my exponent, and a equals, again, there's nothing written out front, so I assume it is 1. All right. Now, my derivative, f prime of x, I'm going to go one term at a time. All right, I have n times a, x to the n minus 1 plus And then I have n times a, negative 4, x to the n minus 1 plus n times a x to the n minus 1. Okay, so time to simplify. F prime of x, or the derivative, is equal to, all right, 1 times 3 is 3. X to the 1 minus 1, that's x to the 0. And if you remember that any base to the 0 exponent is equal to 1. So then that becomes 1, and 3 times 1 is 1, so I'm just going to leave that as 3. I was going to write plus, but I just saw that that's 2 times negative 4. So that's actually going to be a minus, because 2 times negative 4 is negative 8. X to the 2 minus 1 is 1, so I don't need to write that. That's an assumed exponent if we just have x, plus 3 times 1 is 3. X to the 3 minus 1 is 2. All right, and there's the gradient function for the curve. Next. Now this one's interesting. Don't try to do anything weird here. Multiply it out. All right, you can FOIL, you can use the box method, whatever works best for you. So the actual function that we're going to use here, I'm going to FOIL. So first, 3t times t is 3t squared. And then I have outer 3t times 4 is plus 12t. And then I have my inner, negative 1 times t is negative 1t, or just negative t. And then last, negative 1 times 4 is negative 4. Let's simplify that by combining like terms. So I have 3t squared plus 12 minus 1 is 11t minus 4. Okay, so let's go ahead then and do our derivative, or find our gradient function. Okay, now I've got my n, which is 2, my a, which is 3, and my t to the n minus 1, plus my n, which is 1, times my a, which is 11, t to the, that would be n minus 1. All right, let's talk about this constant here. Now, constants go away, and I'm going to explain to you why. Because any constant we would assume is being multiplied by 1, which we've already said is x to the 0. So my term here, negative 4, could be written as negative 4 x to the 0. So then when differentiating, I would end up with n times negative 4 x to the 0 minus 1. But you know what? I can just stop here. And the reason I can stop here is because this whole thing is multiplied by 0. And 0 times anything is just 0. So any constant will end up multiplied by 0 and just disappears. So for us, it can save us some time to say, oh, that's a constant, there's no x term, bye. All right, so simplifying this, f prime of t equals 6. 2 minus 1 is 1, so that's just t, plus 1 times 11 is 11, t to the 0 is 1, so my gradient function or derivative is 6t plus 11. Okay, next we're going to find the derivative if this should be a t, and the reason why that should be a t is because this is a t. All right, so we're expressing this variable in terms of this variable. So you're looking at the change in v with respect to the change in t. So I'm going to rewrite this so that I'm dealing with a coefficient and then a term with a variable and an exponent. So I'm going to rewrite this as v equals 3 halves, that now becomes my a, t to the 4th. So then dv over dt equals n, which is 4, times a, 3 over 2, t to the n, 4 minus 1. All right, 4 times 3 over 2. 4 times 3 is 12, divided by 2 is 6. T and 4 minus 1 is 3. There's my gradient function. Let's do one more. Here, I'm going to write the fraction as my coefficient, and then I'm going to use exponent rules to rewrite this so that I don't have anything in the denominator. So I'm going to say that y is actually equal to 1/2 x to the negative 5. Okay, Because remember, a negative exponent puts it on the bottom of a fraction or in the denominator. So let's find dy over dx, or the derivative of y with respect to x. Okay, so I need n, which in this case is -5, times a, well, my a is 1/2, x to the n, -5, minus 1. And that is going to equal, -5 times 1/2 is -5 over 2, x, and that's -5 minus 1, that is -6. And if you want to put that back the way it was originally written, we're going to end up with -5 over 2x to the 6th. Okay, moving on. The gradient and tangent of a curve at a given point. So we're going to use this function to determine the exact value of our gradient at any specific point on the curve. Basically, we're going to plug in x. So step 1, find your derivative or your gradient function. Step 2, plug in x. Let's check it out. Number 1. So we have this guy here, dy over dx equals, here's my constant, and if you remember, it's going to end up being multiplied by 0, so it's just gone. Here I have n is 4 times a, which is -2, x, y, there we go, to the n minus 1 plus n times a x to the n minus 1. All right, and that is going to equal -8 x cubed minus 9 x squared. All right, so when x is -3, what's the value of the gradient? Well, let's see. When x is -3, I'm going to have -8 times -3 cubed minus 9 times -3 squared. So I'm going to grab my calculator and type in -8 times -3 cubed minus 9 times -3 squared. Be sure that you put your exponents outside the parentheses like I've done here. Don't put them inside. Okay, so I find that the gradient of that curve at x equals -3 is 135, or 135 over 1. All right, let's look at this one. Oh, actually, before we do that, I do want to point out that should your function be written like this, what we're actually finding, where we find the derivative and then plug in a value, can be written like this. What is the value of the gradient function or the derivative when x is equal to -3? Okay. Y equals 7 minus 4x plus 5 over 2 times x squared. Find y prime. All right, y prime, f prime of x, dy over dx, they're all asking you for the gradient function. Okay, so y prime is going to equal, 7 is a constant, and we know that's going to end up being multiplied by 0 if we do anything with it, so it's just gone. And here is 1 times a, which is -4, x to the n minus 1, plus. All right, my n here is 2, but it's on the bottom, so that actually makes it -2. Times a, which I'm pulling from this fraction, is 5 over 2. And then x to the -2 minus 1. Now, if that's hard for you to follow, kind of doing that as you go, please feel free to do what we did up here and actually change the way the function is written before you start finding the derivative or the gradient function. All right. So now 1 times -4 is -4. And I know that that x to the 1 minus 1 becomes x to the 0, which is 1, multiplied by -4. We just have a constant now. And now I've got -2 times 5 over 2, which is going to be -5. X, -2 minus 1 is -3. So to evaluate that now, where x is 4, I'm just going to put -4 minus 5 times 4 to the -3. And I'm going to evaluate that in my calculator. -4 minus 5 times 4 to the -3. And I get a rather interesting decimal. Don't use decimals that are going to require you to round, because then you're not getting the accurate gradient. So I'm going to write this as the fraction of -261 over 64. Okay, point A lies on this curve, and the gradient of the curve at A is 1. Find the coordinates of A. Okay, so the first thing I'm going to do here is I'm going to solve for the gradient function, and then I'm going to set it equal to 1, because doing that will allow me to solve for x, which I can then plug in to my original curve to find y. All right, so step 1, let's find the gradient function. and that is going to be y prime, which is going to equal, my a is 1, I'm sorry, my a is 5, my n is 1. So 1 times 5 is 5, and x to the 1 minus 1, x to the 0 is just 1, so it goes away. My a is negative 1, my n is 2. 2 times negative 1 is negative 2. X to the 2 minus 1 is 1. So here is my gradient function. Now I'm going to set that equal to 1. 5 minus 2x equals 1. I'm now going to subtract 5 from both sides. So negative 2x equals negative 4. Divide both sides by negative 2, and I find that x equals 2. So now I'm going to come back to my original curve and say that y equals 5 times 2 minus 2 squared, because I'm evaluating the curve when x is equal to 2. 5 times 2 minus 2 squared is equal to 6. So the coordinates of A, I have my x value here, 2, and my y value here, 6. All right, let's do another example. We've got 2 points on the curve y equals x cubed minus 6x plus 1, at which the gradient of the curve is negative 3. Find the coordinates of these 2 points and then the equation of the straight line that passes through these 2 points. Okay, first things first, we need the gradient function. And that is y prime equals. My n is 3, and my a is 1. 3 times 1 is 3. And then I have x to the 3 minus 1, which is 2. My n is 1, my a is negative 6. 1 times negative 6 is negative 6. All right, and x to the 1 minus 1 is 0. And then my constant goes away. So here is my function for the gradient. Now, I am actually going to find the coordinates of these 2 points. I'm going to set this equal to negative 3. So 3x squared minus 6 equals negative 3. Okay. I am going to add 6 to both sides. So 3x squared equals 3. If I divide both sides by 3, I find that x squared is equal to 1. So then, x must equal the square root of 1. Now, remember, that's going to be positive 1 and negative 1 because I can get 1 by doing 1 times 1 or by doing negative 1 times negative 1. So x is negative 1 and 1. I now plug each of those back into my original equation to find my y values. So I have, let's do negative 1. Negative 1 cubed minus 6 times negative 1 plus 1. All right, negative 1 cubed minus 6 times negative 1 plus 1 is 6. So one of my points is at negative 1, 6. Now for the other, I have 1 cubed minus 6 times 1 plus 1. My calculator, 1 cubed minus 6 times 1 plus 1 is negative 4. So my second point is 1, negative 4. All right. Now for the final part, because that was A, we found the coordinates of the 2 points. Maybe I should just kind of highlight that we've done that. Let's go ahead and find the equation of the straight line passing through these 2 points. So to do that, I need to find the gradient for the straight line. And that's going to be the change in y over the change in x. So 6 minus negative 4 is 10. And negative 1 minus 1 is negative 2. And that lets me know that I have a slope or gradient of negative 5. Now, I can use either of these points, doesn't really matter. I'm going to go ahead and use this one here. And I'm going to use probably point slope. So I have y minus the y value is 6 equals my gradient, I'm sorry, this should be called point gradient form, times x minus, my x value is negative 1, minus negative is plus 1. All right. Now, if you'd like that in gradient intercept form, from here, that's pretty easy to do. Y equals negative 5 times x is negative 5x. Negative 5 times 1 is negative 5, but we have to add 6. Negative 5 plus 6 is 1. So there you have it. What's next is some practice. If you'd like to pause or stop the video here and work the practice on your own, you can come back to check, or you can work through it with me. That's up to you. All right. We're going to be finding some derivatives. So here, again, we're going to FOIL through and find that f of x equals x squared times x is x cubed minus x squared inner plus 3x, and last minus 3. Now notice here that we do not actually have any like terms to combine. So we're just going to run through and find our gradient function from this. So f prime of x is equal to, n is 3, a is 1, 3 times 1 is 3, x to the n minus 1, 3 minus 1 is 2. Next, n is 2, a is negative 1, 2 times negative 1 is 2, x to the 2 minus 1 is 1, so I'm not going to write it. Next, n is 1, a is 3, 1 times 3 is 3, x to the 1 minus 1 is x to the 0, which is 1. And then a constant will become 0, so goodbye. And there's our gradient function. Let's go to part B. I'll rewrite this. F of x equals, x squared is going to stay the same, minus, I'm going to write 5 over 2 as my coefficient, and that is x to the negative 1, bringing it out of the denominator, plus, I've got 3/4 as my coefficient, and then x to the negative 2, bringing that out of the denominator. All right, time to differentiate. F prime of x equals, n is 2, a is 1, 2 times 1 is 2, x to the n minus 1, 2 minus 1 is 1, so we'll just leave that alone. All right, n is negative 1, a is negative 5 over 2. Multiply that together and I get positive 5 over 2. X to the n minus 1, so negative 1 minus 1 is going to give me x to the negative 2. And finally, n is negative 2, a is 3/4. Negative 2 times 3/4 is negative 3 over 2. And that's x to the n minus 1. Negative 2 minus 1 is negative 3. If you want to rewrite it in fractional form, you can then say that the derivative of your function, or f prime of x, equals 2x plus 5 over 2x squared minus 3 over 2x cubed. All right, number 2. Let's find the gradient of the curve where x equals negative 2. All right. Y prime equals 10 is a constant. Bye. All right, n is 4. A is negative 1/2. 4 times negative 1/2 is negative 2. X to the n minus 1. 4 minus 1 is 3. Let's evaluate that at negative 2. So I have negative 2 times negative 2 cubed. Alrighty. Negative 2 times negative 2 cubed is 16. So the gradient of the curve at x equals negative 2 is 16, or 16 over 1. All right. Point R lies on the curve y equals 5x minus 2x squared minus 3, and the gradient of the curve at R is equal to 9. First, find the gradient function. Second, find the values of a and b if the coordinates of R are a, b. Excellent. So let's find that gradient function. We'll evaluate it when it's equal to 9 to solve for x. And then we will have that as our value of a and plug that into the original equation of the curve to find the value of b, which will be y. All right, so y prime. First and foremost, n is 1, a is 5. 1 times 5 is 5. X to the n minus 1. 1 minus 1, 0. So x becomes 1 multiplied by 5 is just 5. Okay, next term, n is 2, a is negative 2. 2 times negative 2 is negative 4. X to the n minus 1. 2 minus 1 is 1. And I don't need to write that. Next, we have a constant. I know that'll be 0, so bye, girl. Here is the gradient function. So I know that at the point I'm looking for, this is equal to 9. 5 minus 4x equals 9. I'm going to subtract 5 from both sides, and I'll find that negative 4x equals 4. Dividing both sides by negative 4, I find that x is equal to negative 1. Well, that's my x here, so a equals negative 1. To find b, I'm now going to plug negative 1 into my original curve. So that is 5 times negative 1 minus 2 times negative 1 squared minus 3. Okay. 5 times negative 1 minus 2 times negative 1 squared minus 3. And I get negative 10. So that means that b is equal to negative 10. Let's keep going. All right, 2 questions left, 2 questions left. Oh, actually, we don't have 2 left. This is part of the stuff on your next one. So, no worries about that. That won't be on the copy that you have. There's 1 left. All right. So we have 2 points on this curve where the gradient of the curve is 0. Let's find the coordinates of these 2 points. All right, let's start off with finding y prime. Now, y prime I know that my n is 3, my a is 1. 3 times 1 is 3. X to the n minus 1. 3 minus 1 is 2. Here my n is 1, and my a is negative 12. 1 times negative 12 is negative 12. Alrighty. And then x to the 1 minus 1 is x to the 0, which is 1. So that just stays negative 12. And then my constant I know will be 0, so it goes away. Now, 2 points where it's 0. So I'm going to solve 3x squared minus 12 equals 0. I'm going to add 12 to both sides, which leaves me with 3x squared equals 12. I'm then going to divide by 3. So x squared equals 4. To take the square root then, your calculator will just give you 2, but remember that 2 times 2 is 4, but so is negative 2 times negative 2. So you have two values of x, you have negative 2, and you have positive 2. So to find your missing points, you'll plug into the original curve equation. First, x cubed minus 12x plus 5. Let's start with negative 2. So that is negative 2 cubed minus 12 times negative 2 plus 5. All right. Negative 2 cubed minus 12 times negative 2 plus 5. 21. So my first point is negative 2, 21, and at that point, the gradient of the curve is 0. All right, for my next value of x, I've got 2 cubed minus 12 times 2 plus 5. All right, 2 cubed minus 12 times 2 plus 5. I get negative 11. So then my final point is 2, negative 11. All right. Good job, guys. I will see you next time for 2.2 equations of tangent and normal lines. Have a good one.